In this video, I'll be doing an example of proving a trigonometric identity. I have sine theta divided by 1 plus cosine theta plus 1 plus cosine theta divided by sine theta. And I need to prove that this is identical to 2 divided by sine theta. I can either prove the left hand side onto the right hand side, or I can prove the right hand side onto the left hand side. But generally it is much easier to prove the side that is less simplified onto the side that is more simplified. The right hand side seems to be more simplified and the left hand side has more terms, so it would be much easier to prove the left hand side onto the right hand side. And to prove this, I'll be taking the help of the two basic trigonometric identities that we learned earlier. Tan theta is identical to sine theta divided by cosine theta, and sine square theta plus cosine square theta is identical to 1. So let's prove this. On the left hand side, I have sine theta divided by 1 plus cosine theta plus 1 plus cosine theta divided by sine theta. Now on the right hand side, you can see that there is only one single fraction. So I need to add these two. And for that, I'll need to make a common denominator by cross multiplying. I'll be multiplying and dividing this fraction by sine theta and multiplying and dividing this fraction by 1 plus cosine theta. So this fraction would become sine theta times sine theta and divided by 1 plus cosine theta times sine theta plus 1 plus cosine theta times 1 plus cosine theta divided by sine theta times 1 plus cosine theta. Now you can see that the denominator is same in both of these fractions. So I can take it common in a single fraction. The denominator is sine theta times 1 plus cosine theta. And sine theta times sine theta is sine square theta, and plus 1 plus cosine theta times 1 plus cosine theta is 1 plus cosine theta whole squared. I can expand this 1 plus cosine theta whole square by using the formula of a plus b whole squared, which is a square plus 2ab plus b squared. So the numerator would become sine square theta plus a over here is 1, so 1 square plus 2 times a times b. A is 1 and b is cosine theta. So plus 2 cosine theta and plus b square. B is cosine theta, so plus cosine square theta and divided by sine theta times 1 plus cosine theta. On the right hand side, I have no sine square theta and cosine square theta like I have over here. So I need to remove these two. And for that, I can take help of this identity, which is sine square theta plus cosine square theta is identical to 1. So if I add these two, I can write 1 instead. So it would be 1 plus 1 square is 1 and plus 2 cosine theta and divided by sine theta times 1 plus cosine theta. 1 plus 1 is 2, so I can write, if I write over here, 2 plus 2 cosine theta and divided by sine theta times 1 plus cosine theta. Next, if I factor out 2 in the numerator, I would get 2 times 1 plus cosine theta divided by sine theta times 1 plus cosine theta. This 1 plus cosine theta and this 1 plus cosine theta cancel each other out, and I am left with 2 divided by sine theta. And this is what was on the right hand side. So I have proven this identity.